This video is for lesson 6-2. We're going to do some two-column proofs about geometry. Learning goals are to complete some proofs about theorems involving segments and to complete proofs about theorems involving angles. So we're going to work with segments and angles today. Let's start with an example problem involving vertical angles. Vertical angles is a vocabulary word from earlier this year. Vertical angles are the opposite angles formed by intersecting lines. So if you take a look at this sketch here of these two lines, we have angle 1 and angle 2 in these opposite positions from each other. Those are vertical angles. We had an idea earlier in the year that vertical angles are congruent. Let's prove that that theorem is true. So our format for proving that something is true is called two-column proof. All of our proofs this year will indicate what we have given to us to work with, that angle 1 and angle 2 are vertical angles. Based upon that fact and the drawing that shows that to us visually, let's prove that angle 1 is congruent to angle 2. The proof will have several steps logically connected, written in a two-column format. The left column will be statements, things that we write down, and the second column will be the reasons for writing those statements. First step, we could say the measure of angle 1 plus the measure of angle 3 is 180 degrees. We're getting that from looking at the drawing, noticing this straight line here, and that angle 1 and angle 3 sitting side by side together form that straight line. That was that concept of supplementary angles. And so that is our reason that we can say that if you add them together, it makes 180. So the reason is the definition of supplementary angles. Next step, we look at the picture again, look at the other straight line, the one that runs like this, and observe that angle 3 and angle 2 are adjacent to each other and they create that straight line. They're supplementary. And so because they're supplementary, we can add their measures together and say equal 180. The definition of supplementary angles. So that reason was used 2 times in our proof. For our third statement, let's try to logically conclude something based upon the 2 statements we just wrote down. Notice that we have 2 angles adding up and equaling 180. And in the second statement, we have 2 angles that add up and equal 180. Because they both equal to 180, we can logically conclude that that is equal to that. In algebra class, that is called substitution, where in place of the 180, we're substituting this thing here, which is equal to the 180. That creates the third statement. Okay, once we have this, let's create the fourth statement, which is angle 1 is equal to angle 2. Measurements are numbers, so think algebra properties here. Do you notice how angle 3 appears on both sides? We can subtract the measure of angle 3 from both sides of the equation. That's called the subtraction property of equality. That creates statement 4. If the measurements of 2 angles are equal, then we can say that the angles are congruent. We're going to use this reason a lot in our proofs in geometry, going from statements that involve the measure of angles to saying that they're congruent. That's the definition of congruent angles. So over here, all of these reasons are the justifications for making the statements on the left side. This whole thing together proves that this theorem is true. And once we've proved it, we can use it all for the rest of the year. Vertical angles are congruent. Let's try another one together. This time some of the boxes in our proof are missing. We're going to fill them in. Here's a theorem. All right angles are congruent to each other. Let's prove that this is true. For the given part of this, we have angle A and angle B are right angles. And what we want to prove is that they're congruent. So to start off a proof, you almost always write down what is given to you. So I'm going to copy that in the box. Angle A and angle B are right angles. The reason for writing that is what was given. Most proofs start that way. Because angle A and angle B are right angles, what could we then conclude? Is there anything that's kind of almost natural to conclude when you're told that they're right angles? There is. We can say that their measures equal 90. So notice it says the measure of angle A is 90 degrees, the measure of angle B is 90 degrees. That is the definition of right angle. That's what it means to be a right angle, that the measures equal 90. Notice for the third step, if angle A is 90 and angle B is 90, meaning if both angles are 90, what's kind of a natural thing to say about those two angles? We can say that their measurements are equal to each other. That is the substitution property. And then for the last thing, if their measurements are equal, what does that imply about the angles themselves? They're congruent. So what's missing here is just to say angle A in there. Angle A is congruent to angle B, the definition of congruent angles. This statement here, definition of congruent angles, is going to be used quite a bit. It's always going to be the reason that allows you to go from a statement of saying that the measures of angles are equal to a statement that says just that the angles are congruent. It will always be that reason when you have that pattern of logic. Here's another example. Complete this proof. Notice this time none of the reasons are provided, so we're going to have to do some logical thinking to get these. Given Q is the midpoint of segment PR, we can see that drawn in the picture. Notice that if Q is exactly in the middle, we know that that piece is congruent to that piece. Segment QR is congruent to segment RS. So the distance from Q to R is the same distance as from R to S. Let me put a little single mark there too. So all three of these things with these little marks are equal in length. Let's prove that segment PQ, that first piece, is congruent to segment RS, that last piece. We think that they are because we have these little marks on them. Let's actually prove that that's true. Okay, first statement, Q is the midpoint of PR. Where did that statement originate? That was given to us. So you write that down as given. Next statement, segment PQ is congruent to segment QR. That's when I marked that that thing and that thing were equal to each other. How did I know that? It had to somehow relate to the statement that was made just before where Q is the midpoint. That was the definition of midpoint. If a point is a midpoint, then those two segments on either side of the midpoint are congruent. That is the definition of midpoint. That came from an earlier section. You have to remember the stuff from the earlier sections to be able to do proofs. Okay, third statement. Segment QR is congruent to segment RS. Where did this come from? Why make that statement? That was given to us. So that's given. Final statement. Segment PQ is congruent to segment RS. We have to have a reason for making this conclusion. Let's look back at what we had stated previously. PQ is congruent to QR. In turn, QR is congruent to RS. So let's make a logical connection between these statements to say that PQ is congruent to RS. That is the transitive property. If one thing is congruent to another, and that thing is congruent to a third thing, then the first one is congruent to the third one also, the transitive property. Here's another one. This time it's the statements that are missing. I'm going to pause the video for you to try filling in these statements. Use the reasons that are given to you to try to predict what those statements would have said. Here are the answers filled in. For the first statement, the reason was given, but if you look up at this problem, there's actually two pieces of information given. So which one is written down at that point in time? To know, we have to look at the next item, the definition of supplementary angles. If that reason was used to claim something in the second box, then what came before must have been something that involved supplementary angles. And so that's why I selected angle 1 and angle 2 are supplementary. That piece right there from the given. If angle 1 and angle 2 are supplementary, then we can use the definition of supplementary angles to make this statement. If you add them together, it equals 180. In the next step, the reason was given, so I filled in the other piece of given information. Now in the fourth step, it says that something was done and the reason for doing it was the substitution property. So what could have been substituted? Well, in statement 3, we have that angle 1 is 68, so what could have been substituted is the number 68 in place of the symbols measure of angle 1. And that would create what you see here in box 4. For step 5, we were trying to prove that the measure of angle 2 is 112, and we can create that from statement 4 if we subtract 68 from both sides. That creates what we were trying to prove, and it fits over here where it says, let's use the subtraction property. Here's another example. It says, arrange the statements and reasons below in logical order to complete the proof. What we're trying to prove is that angle 1 and angle 2 are vertical angles, and if angle 1 is congruent to angle 3, then prove that. So everything's filled in, but these are out of order. So I'm going to pause the video, and what you need to create on lined paper is a 2-column proof, right? Like this. In the first column you have your statements, and your other one you have your reasons, but which is the correct one to do is number 1, then number 2, then number 3, and then number 4. In what order should those 4 things go? And here's the answer. First thing that should have been stated is angle 1 and angle 2 are vertical, reason given. If you just write down that they're vertical, then the logical thing to say next is that angle 1 is congruent to angle 2. Because of the theorem, vertical angles are congruent. For the third statement, let's put our other piece of given information down. And then for the fourth statement, it has to be the thing you were trying to prove. The thing you're trying to prove is always the last statement in the sequence of statements. Here are some check your understanding questions. I'll pause the video for you to solve all these. Number 1, if we know that angle D and angle F are both complementary to angle J, what statement can we prove using the congruent complements theorem? Kind of glossed over this in the video to save time, but if you looked back a page, you could find this theorem. But just the name of the theorem is probably enough hint. Congruent complements theorem means that if 2 angles are complementary to the same angle, then they must be congruent to each other. So we can say angle D is congruent to angle F. Number 2, what types of information can be used as reasons in a proof? We can use definitions, postulates, and theorems. Number 3, Kenneth completed a 2-column proof, but he made a mistake. How can we correct the mistake? Here's what's given to us, and here's what we're trying to prove. So he started his proof by copying down that piece of given information, and he said given. That's okay to do that. Then he said angle KJL is congruent to angle LJM. He looked at the picture KJL and he said that angle is congruent to that one. He gave us his reason, the definition of congruent angles, and that's where the mistake is. If the previous statement used the word bisect, and you want to conclude from that that means that 2 angles are congruent, that should be the definition of angle bisector. So what he wrote as the reason in the third step should actually be the reason in the second step. Then in the third step, from the statement that the angles are congruent, he wanted to say that that means the measurements are equal. That's the definition of congruent angles. And so that part right there he should have put in the third step. He got his 2 reasons backwards. That was his mistake. In this lesson, we tried some example proofs of theorems involving segments and some example proofs for theorems that involve angles. Remember that once theorems have been proved, you can use them as the reasons in other proofs later in the year.